Hey everyone, welcome to today's show. Today I'll talk about XDR. Now, this concept is not new. However, there's a lot of confusion around it, and the reason I know about this because I keep talking about it, and I have friends who know about it, and they work across industries, various companies, and they have a bit of different definition depending on where they work. A lot of customers are looking at XDR and they're confused because when they hear from various companies who are building these platforms, they get confused too. Okay. So that's what I thought I'll cover today. Now, people who are listening this on an audio medium like a podcast on Spotify, Audible, Geo 7, etc. I have a YouTube channel and I'm showing a mind map of what I'm talking about. So it's better if you look at the mind map. However, I'll try to ensure that I am covering everything so that you don't need to visit. Uh, but if you like to take pictures, if you like to take notes, it's better if you attend the YouTube content. With that, let's get started. Now, XDR stands for Extended Detection and Response. Okay. Now, before I talk about this specific domain or technology, you have to have some historical context of how security operations are run. Okay. So, essentially, in security operations, there is detection tech and response tech. So, extended detection and response essentially has components from two technologies, detection and response. Now, just to remind you, in any enterprise, there are prevention technologies, detection technologies, and response technologies. Now, our focus will be detection and response technologies, for which there is a team of Security Operations Center or SOC. Okay. Now, starting with detection technology, the oldest being there is SIEM or Security Incident and Event Management. And if over the years it got evolved into security analytics, UEBA, etc. Now, the job of this technology is to collect logs and alerts from infrastructure platforms like servers, endpoint, security technologies, applications, etc. Also, databases, by the way. What it does, it once it takes the data, it correlates or finds common patterns in this data. It also finds anomalies by running simple algorithms as well as AI based algorithms on the incoming data, and also rules or policies written manually by the end users of those platforms. Once anomalies are found, they are considered as alerts, and these SIM platforms or UEBA platforms have a native case management capability, mostly basic in nature, where analyst can log in, he sees the alert, does an investigation, and decides if it's an incident or not. Typically, alert means this looks bad, but incident is it's really bad for the organization or it has an impact. Now, these technologies have evolved over the years. So, SIM started with log collection, and security analytics meant applying analytical algorithms, and UEBA started with user-focused use cases and endpoint-based use cases and building behavior based capabilities around it. So that's how technology has evolved, and SIM is the most commonly deployed platform today. It's a huge market. To my understanding, the last data point I read is globally it's around $7 billion at least. Okay, with that, the other technology which is very prevalent in the SOC world is EDR, which stands for Endpoint Detection and Response. And what it does is it collects data from endpoint. What this data includes, its activities like process creation, file access, network connection, registry changes, etc. So, example, whenever you're launching a browser, it creates a new application processes, and in fact multiple processes. You type a URL, let's say google.com, in the browser, it creates a network connection. This network connection would most probably go through a SASE platform or a firewall uh, or a VPN, depending on the organization context or the architecture. And this connection is stored as an event in the SIM. Okay. Now, going back to EDR, so what EDR does, it keeps monitoring or collecting data by deploying an agent on the endpoint machine. Okay, so uh, it is monitoring all that activity, and it is then comparing that activity using a similar process like using a SIM, but more focused on endpoint activity. So the anomalies are again found by running simple as well as AI-based algorithms and any policies or rules that are created by the end user of the or the admin of the EDR platform. Okay, again same concept. Anomalies are considered as can be considered as an incident, and most commonly these are sent to SIM or SOAR if it's available. I'm coming to SOAR. So okay, so comparing again, SIM collects log activity or audit trail from infrastructure devices and finds anomalies. EDR collects endpoint related activities and find anomalies. So both are collecting data for various use cases and finding anomalies out of it. Okay. The third technology that's relevant, although not that common, is NDR, NTA or NAV. NDR stands for Network Detection and Response. NTA stands for Network Traffic and Analytics. NAV stands for Network Anomaly and Network Analytics and Visibility. Okay, it depends on who you're talking to. Different analysts, different companies have different definitions, but concepts are same. Now, NDR, NTA, NAV do the same thing. What in essentially the same concepts, which is it collects network data from various network infrastructure points like firewall logs, net flow, which is essentially a statistical based report or connection report of what connections are being made by various systems. Also full packet captures, mostly when the end user is making a connection to internet. So example, when I'm going to, let's say, a site called abc.com and I'm downloading a file called 1.pdf, this file will be captured by the full packet capture. A firewall based log will say, okay, Prashant went to abc.com, connection successful. Okay, netflow based information will say abc1.com http protocol these many bytes. Okay, so firewall also keeps that data, but it's mostly in terms of http connections allowed or denied. Okay, so you have different levels of network related information. With full packet capture, you can download the exact file. Now again, same concept. Anomalies are found by running various algos or by manually writing policies. So example, a policy could be send me an alert if you find a PDF which has a inbuilt JavaScript. Although it's very common, but there were days that when it was not common. But I believe you get the gist of it. Again, if there are anomalies found or alerts that are found, they are sent to SIM or SOAR if it is present. Okay. Now let's look at threat intelligence. Now threat intelligence is a supplementary technology, and what it does, it contains information about capabilities, intentions and activities of threat actor. Okay. Essentially, in the most simplest form, it is a technical side. It contains a collection of IPs, URLs, domains, file hashes, which are shared through various sharing mechanisms, like simply emailing the file, putting it in a shared drive, or in fact there are various technologies for sharing threat intel information like Stix and Taxi to make it more automated. So threat intelligence platforms are typically integrated with other detection and response technologies to provide more context of the ongoing cyber activity, and also to help make better decisions about the attacks. So for example, if you see that Prashant went to abc.com and downloaded a file .1.pdf, but abc.com in the past has been used by a threat actor in Russia, you would most probably like to investigate further, or in fact in some cases might even block it if you don't have any activity related to anything in Russia. Okay. Now, so threat intelligence is a complementary technology. Also, then each of these tech has its own console, its own backend database, and it has no context of each other. Okay. Now, what that means is, Prashant, going back to the same thing, opens a browser, chrome.exe is launched. That activity is captured by EDR. Prashant goes to google.com, downloads a file called 1.pdf. This is captured by EDR, as well as now, because the connection is going to internet, it is captured by NTR, NTA, also the firewall log data, which will be then sent to SIM. Okay. These three technologies are capturing the same information, but they have no idea of the overall context, which is this is one person who's trying to do a simple thing, because these technologies are disjointed and they don't connect with each other. Now, what SIM tries to does it SIM typically wants to or connect these dots, which we typically call correlation. Essentially, it's about finding common patterns. So SIM tries to do that job, and it's done a decent job, but a lot of things don't get captured in SIM because there's not log activity doesn't exist for everything, right? Everything cannot be captured if but everything can be captured in NTA, but NDR is so expensive because of the amount of data that's generated whenever some activity takes place, and it's hard to retain that data for a large organization. So for example, if somebody is monitoring 100 Mbps of link and capturing every traffic for all the employees, it's 100 MB generated in 1 second. Imagine the kind of storage that you would need for this kind of activity by end users. Now let's go back to detection tech. So quick summary, we understood that there have been SIM, security analytics, UB technologies, EDR, NT, and NAV, so threat intelligence technologies that have existed on the detection side in the SOC. Let's move on to the response tech. Now, response tech has been there for some time. The most common form has been ITSM, and in last 4 or 5 years, SOAR has actively taken over. But what ITSM does is ITSM provides a central incident management, and it helps organization to resolve incidents. Essentially, what it does in the most common summary is ITSM is a tool where businesses resolve IT tickets. So let's say I have a laptop issue, my screen is not working, so I'll open a ticket in the ITSM portal, and somebody from the IT help desk will call me and help me with troubleshooting the issue. Okay. Now, same tool can be used by security teams to investigate and perform their day-to-day activities. Okay. Now, SOAR is also getting common now, although not as widely deployed as we would want to be, but it will become more common as automation is picked up by most companies. SOAR stands for Security Orchestration, Automation, and Response, and what it does is it automates workflows related to investigation and response in SOC. So again, going back to the same example, let's say when Prashant downloads one .pdf and it leads to an infection in the system, this infection is detected as an alert by EDR. EDR sends a ticket to SOAR directly or via SIM, and SOAR might have a workflow which says, hey, isolate Prashant's machine till we call him and find out what he did. So instead of somebody calling and disconnecting my system or disabling my network card by call, the antivirus running on my system will do that automatically based on an integration with the SOAR and a command sent by SOAR. Okay. So what SOCs do is they have detection and response tech working together. So anything that is detected by the detection tech, the workflow in the response tech tries to automate it. And most companies strive to go for as much automation as possible to provide better productivity. Now, this is some brief context on how technologies are used in SOC. Let me tell you how I've seen them evolving, because when I started in cybersecurity, and this is 2003, 2004 type, a lot of these technologies were not common. I mean, Google wasn't even common then. Now, SIM, my first SIM experience was in year 2007. I started learning or working on SIM in that year, and it was very common for people to use SIM. It was evolving. People were sending logs. They were writing rules, and analytics or ML based anomaly detection didn't exist at that time. Okay. A few years later, in 2011-12, I got the opportunity to work on an EDR solution and an NDR solution, and these things were getting very popular. But at that time, there were separate agents for EDR. So antivirus or endpoint protection, as we call it today, that had a different agent which would protect you from the malicious threats on endpoint, and then there would be an EDR agent continuously collecting your activity. Okay. Then threat hunting became a popular term over the years, which is using these products, the detection products, to find malicious activity proactively by running queries. Okay. Again, or 4 different detection technologies, 3 or 4 different consoles to do threat hunting queries. Okay. Then Source started coming in 2018. I mean, of course it was under development before that, but I was able to get my hands on to a SOAR in 2018 period. Understood about that domain, and later in 2019 or 20, I believe XDR started to become as a term, and now CDR is getting popular, which is any detection and response on the cloud workloads, because cloud workloads are a bit more complicated than a standard workflow. So example, in a server which is, let's say, a Unix or Linux based server, if there's an issue, you simply go into the log files and find all the issues. Okay. Log files, you typically know the log file location. In Windows it's one central place. In Linux there are few log files. Now imagine the same thing running in a public cloud like Azure, AWS or GCP. There are logs of these systems, as well as then there are services logs. So because of the way CSPs work, and if I've enabled more telemetry, you have to look at more places, and it makes it a bit complicated. Now, with so many technologies available, the issue is that there are too many alerts coming, right? So fatigue, and security analytics tries to reduce that. People try to automate all that, but eventually what it leads to is slow response and investigation time, right? And there's a concept called MTTR, mean time to respond, mean time to detect. These are things I don't want to go deep into, but essentially they help you track performance over time of how SOC teams or security teams are functioning. So technology has evolved a lot in last 10-15 years, as we all know, especially on the SOC side it has been there. Now again, what has not happened is the contextualization hasn't happened. Okay, which is everything in a real world is same. Prashant is trying to launch a go to a website and downloading a file. It's me doing one simple activity. Okay, on the infra side, on security infra side, it is more complicated because it is managed and detected or protected by multiple platforms. Okay, so it's not connected. Now that's the history. Okay, I know it's been a lot, but it's important for you to understand if you want to understand how XDR, because most people who are looking at XDR will have some understanding of the historical context, that they are using tools of these historical contexts. And by the way, history in today's sense is, in the SOC sense, could be 2 or 3 or 5 years old, not okay. Mostly tech evolves. Now, what is XDR? Let's look at the analyst definition. So Gartner says it's a SaaS-based vendor-specific security threat detection response tool that natively integrates multiple security products into a cohesive security operating system. Good. Forrester, on the other hand, says the evolution of EDR, which optimizes threat detection, investigation, response, and hunting in real time. XDR unifies security and relevant endpoint detection with telemetry from security and business tools, etc. It talks about NAV, email security, IAM, cloud security. It also says that it's cloud native platform built on big data infrastructure. So it's a big definition. Okay, so I recommend you to Google it. Just Google Forrester or Gartner definition, and thanks to them for coming up with these definitions, because it helps. I personally find them bit complicated unless you come from a hardcore domain of cybersecurity. But once, if you are trying to evaluate, it becomes complicated, because company one could have one definition, company two could have a different definition, and you're confused, right? So here's my definition. So XDR, as per me, is evolution of current detection and response technologies like EDR, SIM, NDR, which are provided as a SaaS or on-prem capabilities, preferably SaaS, with an objective to make threat detection and response easier. Okay, I'll repeat this again. So XDR is an evolution of current detection and response technologies provided as a SaaS or on-prem option with an objective to make threat detection and response easier. Okay, now once you remember that, you can go to any vendor, any technologies, and just start mapping this definition with what they are saying. Okay, so the key thing in this for me is, because it is evolution of EDR, SIM, and NDR, and evolution has to be better, which means I can't have three different front ends for each of these three distinct technologies and response technologies. I got to have a single front end, single back end, because what happens when I have three consoles and three back end, I'm paying more for storage and we're spending more time in clicking on tabs, logging on, managing their access, etc. Okay, so in XDR, the key thing is single front end, single back end in terms of architecture. The other thing is it should have use cases that are spread across threat detection on SIM, EDR, NDR, with the capability for threat intelligence fusion and SOAR. Okay, so it's essentially consolidation of these detection and response technologies. And why is this important? Because the moment you have a single front end, your productivity improves. The moment you have a single back end, the data can automatically be correlated or connected. Dots can be connected by the system algorithms. The backend database itself or data lakes are itself so smart today that you don't have to find or do or carry out complicated stuff. The graph technologies, the way they provide linkages, is just amazing. Okay, and of course, with more data comes better AI, better output. Okay, and because all the data is in one place, it's easier for AI because it sees everything in one context. It's Prashant who's going to google.com or that abc.com 1.pdf downloading this stuff, and it was flagged by a threat intelligence, and I now have to automatically block it, but block his machine. But before I do that, let me pull a dump of what he did in last 30 minutes, why he suddenly went to abc.com, why I don't have to uh, you know go into other users machines and all that, right? I hope that made sense. So that's the simplest definition. Okay, now who's talking about these terms? Okay, is typically you will hear XDR from EPP EDR vendors, and these vendors have a strong EPP EDR, and what they are doing is they've either acquired or they're built a native log management platforms. Essentially, they're trying to get the use cases, the threat and detection and response use cases from the log world. The other category of people who are talking about XDR is SIM providers, so people who have a strong SIM-based solution, and they have a capability to ingest data from third-party platforms using OpenAPI. So OpenAPI is good. The problem with that I see with that approach is it's hard to pull all the telemetry from third-party products. Again, there will not be a single front end and back end. You will eventually have to jump into the other console. Even if you manage to handle that problem, you will store the same amount of data at two different places, and typically it will be very hard to pull real-time data from a different system using API at a larger scale. Okay, the other category of OEMs talking about and XDR would be NDR, NTA, and AV vendors. Again, same concepts like SIM. They will have strong NDR capabilities, and they will talk about Open API, and they'll say, "Hey, I can do this. I'm an XDR." And the last category would be MDR providers. So it's a term that's often get confused in this world. So MDR providers are essentially companies who provide services, which means they will have an XDR platform along with the people to offer MDR as a service or XDR as a service or EDR as a service, depending on the detection and response technology. Okay, so they are most probably not building their platforms. In some cases, they would be, but the concept is that they will have people as well as platform to manage your detection and response issues. Okay, now let's look at how this technology is gonna work as per my understanding. First, data collection. So as you can imagine, it will have the capability to collect data related to endpoint activity, activity from infra, application side, SaaS side, databases, so all those traditional SIM capabilities, EDR capabilities, network data capabilities would be there, which means it will have most probably an agent as well as SIM-based mechanisms like log collection, push and pull methods, syslog, ODBCs, JSON or API based data or alert collection, all that will be there. Okay, they will have analytics. So again, AI models, same like EDR, NDR, SIM, AI models that can understand this data and can profile it. Of course, because now you have different data sets, you will have more models available. Okay, if not hundreds, thousands, right? uh, and more, right? And these would be focus on finding anomalies across user activity, application activity, endpoint activity, workload activity, etc. You whatever scenarios you can come up with, it is should be possible with that XDR. Okay, and of course response should be there. So SOAR and threat intelligence should be inbuilt. It should be easy to write workflow automation, as well as fuse third party threat intelligence or native threat intelligence, whatever is available. Okay, architecture is SaaS or cloud based. So I know some companies are talking about on premise XDR platforms. I see that an issue, because with XDR, uh, one key capabilities is one single platform that does it all. What that means is you have to collect more data, and typically on premise platforms will not be able to scale because of the infra limitation. So a hardware can only come up with so much storage, right? So a SaaS based storage is better, because there's unlimited scale in that. So a SaaS platform or a cloud based service is much better. Okay, because it will give you flexibility to collect as much data, uh, and run as many models and retain the data for your compliance requirements. Okay, now, are these capabilities available today? Yeah, some of them are. Okay, people are still building, we are innovating, more use cases will come from the industry, but it's coming, because as humans we want to be more productive, so it will happen. Companies are already working on it. In fact, I'm seeing things like email coming, data from CASB, anything that is around user activity, application activity, all that will be converged to find threat detection, or find threats, make threat detection easier, response easier for SOC industry. So yeah, that was it for today. uh, if you have any questions, reach out to me on my Twitter handle. I do get questions on my LinkedIn ID also, happy to answer them. Also on my YouTube channel, my Twitter handle is available in the podcast descriptions. I'm thankful to anybody who heard this, and please like, share, subscribe. Let's make cyber simple. I'll see you next time. Thank you.